cloud computing and some of its benefits. I'll do my best not to bore you guys out. Also, it would be cool to have some level of interaction. So please feel free to drop your questions and comments anytime in the chat box. I will answer them as soon as I can. I'm sharing my screen now. Okay. Um, okay, so let's start with what cloud computing is. What is cloud computing? I mean, I'm sure we all ask ourselves every once in a while. We hear cloud here, like waiting with this cloud safe. Um, so I'm just going to read this out and then explain it in maybe simpler terms. Cloud computing refers to the use of hosted services such as data storage, servers, databases, networking, and software over the internet. This data is stored on physical servers, which are maintained by cloud service providers. Um, in English, cloud computing is basically um, managed services. It is you keeping your data somewhere, not just your data, your server, your storage, your databases, networks, all those things, to be managed either by a private IT infrastructure owned by you or by a public cloud service provider. Um, the architecture of the cloud generally would be all these resources we say the cloud manages for us, like servers, virtual desktops, application storage data, um, are all what we call cloud computing itself. This is what the cloud itself helps you to manage. And then you, the user or a developer or other people like that, have some sort of access to it via routers and switches. So this is just networking terminology, but at the end of the day, most of this is abstracted from you, the user, because that's one of the goals of cloud computing itself, to abstract as much from the end user. Some of the business advantages of cloud computing itself would be things like data security, cost efficiency, scalability. So you hear most people say things like, "I want to move my application to the cloud." Why? Because last month I had 200 users. This month I have 1,000 users, and we are getting trouble. Everything is crashing. We can't manage it locally as good as before anymore. But I think maybe AWS can help me do this. So I want to move my information to the cloud. Um, Cost efficiency, yeah. Depending on the kind of setup you have, you can save a lot of costs by using cloud providers, or whether private or public cloud providers. Yeah. Data security. Most times, many of these cloud services have their own security set up for you. Yeah, they have their own security set up for you, and you don't need to even worry a lot about where your data is stored, because it's probably somewhere in Europe or it's somewhere in the US. Um, many of these services bring some level of advantage to what cloud computing itself is. Most times, it helps us take away our worry from many of the things like that we would normally worry about. So, for instance, now if you were building an app, yeah, I'm just going to pick somebody randomly from the chat. If Abdullahi was building an app, he would say, "Oh, I want to build the app. I want to host it somewhere here. I want to keep all the infrastructure the app requires to work mm, locally. I think I can run it from my computer." Then tomorrow, what Abdullahi did not plan is that, oh, when I do this app and maybe I host it on Google Host or something like that, what happens when I have like 1,000 users or 1,000,000 users? Yeah, you start considering other options. And it's not just the option of what is hosting your cloud, it's also the option of um How do I manage all the services I am providing to people? How do I checkmate all of this without having to trade off certain things? Yeah. So this is generally the business advantages of cloud. Yeah. Um the next thing will be the architecture of cloud computing itself. I'm not going to dwell too much on this at this point, but we'll still discuss it a bit more in depth. So normally, where the cloud will give us advantages instead of storing our files and things like that on hard drives, you as a user can store them on the cloud. Make it possible for anybody from anywhere in the world to access your files. This is the general concept of the cloud. That as far as you have access to the internet, then you have access to the cloud. Mm. Um, this architecture can be divided into two categories. We can describe the architecture of the cloud based on the location that our applications or information or whatever is deployed to, and then we can also describe it based on the service model. Yeah. For the location, we have private cloud, public cloud, and hybrid cloud. While for the service model, again, please, whatever looks confusing, if I am moving too fast or anything, maybe there's a lot of information to take in, please feel free to comment on the chat. Yeah. Um, yeah. So, based on deployment, you have the private, the public, and the hybrid cloud. Well, based on the service model, you have um, infrastructure as service, platform as service, software as service. We'll go a bit more in depth in a bit. So types of cloud, like we said earlier, we have the private cloud and the public cloud. Yeah. The private cloud now would be a type of cloud computing that um, requires you to set up your own private IT network. So typically, I don't know if you've heard things like on-prem before in the past. Yeah. So most times people isolate on-prem, that is on premises, from the cloud. Yeah. That is, oh, I either have an on-prem setup or a cloud setup. Most times an on-prem setup is also a cloud setup, but is a private cloud setup. But this does not have to be the only case. This is just a category of this setup, yeah. Because I mean, I've also heard enterprise, like if you can see, it's also called internal enterprise or corporate cloud. Yeah, it's only managed by the IT team of a particular company. So if I say now, if you see the example there, if I say now that Rashida Enterprise Limited wants to set up servers and network them on premises to deploy maybe she's creating a driving school application or so. uh, and in the future she also wants to make use of Amina is another company, Amina Limited data center. You can see it's an on-prem setup here, but she's also using a third party to manage her cloud service. Yeah. So an on-prem setup does not necessarily mean it is just in your own data center. A data center is somewhere where you keep a group of servers to just think of it as a big room with a lot of computers. These computers have different purposes. Um, some of the computers are just there to serve files. There are computers specifically for reporting. There are computers there just for the sake of networking. But it's just a very big room. Now, this may not just be a room. It may be a span of like acres of land, and so depending on the size of the data center here. So an on-prem could be you having your own data center and setting up everything locally, your IT infrastructure, your IT um what's the name? Your IT guys are going to manage all of this. It is local to you, and even if your IT guys are not managing it, what I'm the point I'm trying to drive at is that it's internal to the company, and then even if it is third party, security measures to ensure that it is only the company that is using it. Like if you see here now, it is company A's cloud, for company A, there's no other company sharing their cloud with them. So even if it's a third party that is managing it, it is still specific for them. So this is what the private cloud is. And even okay, when I get to the public cloud, I'm going to say something else about the private cloud. The public cloud instead now is computing services offered by a third party providers. I'm sure most of you, your head must be ringing AWS now or GCP and things like that. Yes, these are public cloud networks because almost anybody has access to them. Now, this does not mean anybody has access to your data, but it means anybody has access to these cloud networks. AWS they have data farms everywhere, they have data centers everywhere, and they create what's the name? They create on demand, the provision on demand resources for you based on what you need. Yeah. So yeah, I said I was going to say something about privacy in the public cloud. So even in the public cloud, yeah, sometimes you create things like a virtual private cloud. So you can create your own private cloud infrastructure inside the public cloud. It's just you're using a public um, service provider, a public cloud service provider, but you can still have your own private cloud inside it. I think this sheds some sort of clarity between private and public cloud. For example, I'm just going to pick a user here. For example, Francis's company decides the overhead managing of their own computing cost maybe too much because maybe they have to employ a lot of people to be managing servers and they need too many IT guys and stuff like that. And at the end of the day, it's not when you compare it to their results, it's not that exponential. So they say, why can't you just use a cloud server, a public cloud service provider, yeah, and have them manage some of these things for us. So yeah, it has its advantages and it does have its disadvantages too. Um, and the third category here will be the hybrid cloud. So the hybrid cloud will be where you require some of your resources to be private to you and you require some of your resources to be in the public cloud. So again, it is specific to how the company is being run and the needs of the company most times. Yeah. So you can say, oh, for the sake of cost, I'm going to host certain things on the public cloud. I can't be setting up Kubernetes clusters on premises. Yeah, it's too much stress. I've spent a lot of time. I've spent money buying switches and whatever, and we are still not getting the network right. Yeah, we've bought switches, we've bought routers. We are trying to provision public IPs all the time. It's becoming too cost intensive and time intensive. So I would just use my public cloud for things like Google now, for instance. I would use Google Kubernetes engine for things like Kubernetes, but then still I can have my backup on my private cloud, or even not the backup, I can say my small apps, I can keep them on my private cloud and manage them myself. So I don't have to pay for all the cloud services. I'm a bit surprised that I'm not seeing any question or comment in the chat yet. Guys, is it boring? Is it boring so far? Anybody? Anybody? Okay. Thank you, Apply. All right. So I have a pictorial representation of the second part also. So remember we spoke about two models here, two categories, which is based on deployment and based on the service model. We just talked about based on deployment. I also like to call it location. Yeah. So now based on the service model, I put this diagram here because it is it gives you an overview of the whole thing. Yeah. So you must have been hearing things like on-prem for sure. Probably not. Yeah. Infrastructure as a service, platform as a service, software as a service. So most times, most people want you to think of what is being offered when you say infrastructure as a service. They say, oh, we give you the whole infrastructure. You don't have to manage this yourself. Or platform as a service or software as a service. But here in this diagram, it pictorially represents what you manage versus what is managed for you by the cloud. Yeah. Oh, by the way, I've been saying service model. A service model is just a collection of components, also known as configuration items. So each of these guys, functions, data, application, runtime, they're all components here. So service model is just a collection of these components here. Um, so on-prem, for instance, now, so wherever you see orange in this diagram, it is what I am managing myself. Wherever you see blue in this diagram, it is what is being managed for me. Yeah. So in an on-prem setup, you manage everything yourself. The functions. Okay, let me start from the lowest layer: the networking, storage, servers, virtualization, OS, backend code, runtime, application data, and functions. You manage everything yourself. Yeah. In IaaS, that's infrastructure as a service, you get some level of abstraction here. You don't have to worry about what is being networked, what is being stored, how the storage itself works. So you can worry about what is being stored, how you push the storages, but you don't have to worry about how the storage works, whether you need to provision your disks and things like that. Yeah. You don't have to worry about servers, you don't have to worry about visualization, but you still have to worry about a lot of your code level stuff. Yeah, there are notes here, by the way. So when this material is shared to you, there is a bit more detail in these notes, and there are references on where you can find some more information here. So you in infrastructure as a service, you don't need to worry about what you are. Oh, sorry, Abdullah. You said I'm fast. Sorry about that. Let me pace down a bit. Let me pace down a bit. And by the way, like I said, if you have anything in terms of conversation, whatever catches your eye, you don't have to wait till the end to ask. Just drop it in the comment section. If we don't discuss it now, we'll discuss it at the end of the conversation. Yeah. So um again, feel free to bomb the chat section. Okay, so like I was saying, in infrastructure as a service, most things you don't need to worry about would be the network storage, the hardware, basically. Yeah. While you worry about your application, the OS it runs on, and things like that. Yeah. Well, in platform as a service, it takes away a part of the hardware for you, just like what Docker does for you, right? If you've used Docker before, you see you don't need to worry about which OS it's running on and things like that. It has abstracted many of these things, even in its runtime environment. Yeah, it has abstracted it, and you only have to worry about building your app, making your app work, the data your app uses, and functions. Yeah. Well, software as a service would simply be like the meeting we are using now. So you are just an end user. You don't have to worry about anything. You just use the software to do what you need to do. Yeah. You don't have to worry about both hardware and software. You just do what you need to do. Yeah. Um so that's basically it if we are looking at all of this from a service model approach. So like I said, these are notes. You can take a peek at them and understand this better also. You see, most times platform as a service has this pay as you go model. You only need to pay for what you use. Next we'll be talking about cloud computing service provider. Now we know we have the big three. Yeah, we have the big three service provider. That is AWS, GCP, and Azure. Those are the most common names here. But then in the oh sure, good question. We'll get to that. We'll get to that in a bit. So but then yeah, most times we will we have other service providers. So take for instance, AWS, GCP, and Azure are all in the US, right? If the US um, does some policy now, yeah, and says, oh, we need to start charging everybody extra because of um, because of what's the name? Because of taxes and things like that. We want to start um, giving people, like making people pay more because of taxes. Yeah. Um. What then do you think people would do? I think people would have to consider other cloud providers. Yeah. Because you start thinking, what if it gets worse in the future? And so you see companies that will say, oh, we have some of our services on AWS, for instance. Maybe we are using buckets on AWS. Maybe we are using some sort of um, APIs on GCP and things like that. Yeah. But we we don't we don't want to rely on any of these cloud services. Yeah. So we want to try out others like Ovio in Europe, for instance, or Yandex in Russia, or Huawei Cloud in China. Yeah. That way we and then there's also Alibaba. That way we reduce this stress on what we're actually doing. Yeah. So it's good to know that while you are scoping your head to the big three, that these are the big three um, cloud computing service providers, that there are others, yeah, that there are others. And a lot of companies will even want to try out other approaches, like set up their cloud themselves. And that's where we said things like, what's the name? Things like on-prem will come in, yeah. Things like on-prem or private cloud basically would come in. So we have others like IBM, Salesforce, Alibaba, Oracle, and VMware here too. Um, Now this is a common question, yeah. What cloud platform is best for me? So my first question would be, who are you? Are you a company or are you learning the cloud, right? So if you're a company, there are factors you need to consider. I won't say, oh, just go ahead, pick AWS, it is the best. Or no, pick GCP, it is the best. I would say pick this at this time because it would give you this, and your company needs this specifically. So now let me fill in the gaps with those this. You need to consider certain factors like reliability and availability. You have to check the track record of a cloud service provider and see that, the SLAs they've set, like for instance, would give you, if a cloud service provider said, we like GCP, for instance, they say, irrespective of what happens, you always get 90% uptime. Yeah. That is, let's say out of 30 days in a month, you can't have any downtime that is less than what 2 days in a month or so. So you'd always have 90% uptime. You need to check this, like, oh, are they actually sticking with this guy? Yeah, have they been honest with this? It's their own track record. Because why this is important for you even when you are learning is because you can join a company tomorrow as a cloud architect and they ask you, oh, we've been getting suggestions that we should move from AWS to GCP. What do you think about it? How do you think we should go about it? Yeah, this is your approach to it. These are the points. These are some of the points you need to check yourself. Yeah. So scalability, you need to access the cloud provider's ability to scale resources up and down based on your needs. You need to know that, oh, if your needs go extreme, can this cloud provider actually handle it? So why this is not a worry most times is because many people work with the big three. But if you are working outside these guys, these may be things you want to check closer to see whether they have all these things. And there is performance, security. It's important. I mean, if your data on the cloud is not secure, well, why are you not just doing it locally? So it becomes a problem for you. Security is always a big deal. Then cost and pricing, very big parts too. Very big parts too. You want to compare and say, if I am running four machines, like four virtual machines on this cloud versus I'm running four virtual machines on this cloud versus running four virtual machines on the third cloud, like which one would be cheapest for me and still give me what I need? Yeah. You want to use that to pick that, oh, this one charges me per minute and over 1 hour, I get this amount. I pay this amount. So you want to eliminate all those options before you pick a cloud service provider. Then service offerings, you want to see how many services, like if I want to do AI today or ML, right? Can I, can I use this cloud provider I'm starting with and say, oh, these guys would offer me AI, and they have things that would work well. They have machines that will work well for my models and things like that. Yeah. You want to check out interoperability too. Yeah, integration and interoperability, how quickly you can integrate with other systems, how does it operate with other, like its data transfer mechanisms, and how it works in a multi-cloud architecture. So for instance, now GCP have been working on doing some kind of multi-cloud Kubernetes, where you can link your Kubernetes cluster on maybe AWS. It was in, I think, maybe last year's Google I don't remember, or maybe Google Next. So where you can link Kubernetes from another um cloud service provider. I think they're using AWS for a use case now, to GKE, and you can manage everything from there. That is very good interoperability, because most times you have to switch context and switch between cloud service providers to do some of these things. Um, you need to check whether its management tools are easy to use. Yeah. So you need to see how easy you can maybe set up monitoring, like its own managed monitoring tools, automation capabilities, navigation for yourself also. How easy is it for you to navigate and things like that? Yeah. You need to check its customer support. If you hit a problem now that you can't fix for yourself, are they available for you? Can they, can is AWS support or GCP support, like, can they quickly do they quickly answer tickets and things like that, or do you have to wait long before you get solutions to your problem? Yeah. You also need to check their innovation and future readiness. For instance, I just stated an innovation now that GCP, like future readiness also, that GCP is planning to deploy. Yeah. So you need to see their plans for the future. Where are they going to? Do they look like they align with where your company, for instance, is going to in the future? So these are certain things you need to worry about as a company, or if you are choosing for a company, when you want to choose a cloud platform that is good for you. Yeah. So it's not general advice to just say, oh, like by default, AWS is the best or GCP is the best. Sometimes your company has specific needs. Sorry, I'm not mentioning Azure a lot. Azure is the best too, example. Um, so sometimes your company has specific needs, and it may just be that what you've been suffering with is cost, and what you are even paying plenty for. Another cloud service provider is doing better in that regard. So you need to factor all of that in. Yeah. As a learner now, yeah, I would say at the top of this list, I mean, it is what is at the bottom of the list, but I would say at the top of this list, as it is now, especially in Nigeria, would be career opportunities and market demand. Yeah. You While you need to consider all the other factors, you need to check that the career opportunities in this cloud service provider I'm choosing to use are there, and there are a lot, to a reasonable amount. Yeah. So we have to be realistic here. You're not just learning this thing to know. You are learning this thing because you probably want to build a career in it. You are learning this thing because you want to grow. You want to make money. I mean, we all do, right? So you need to check what the market demand is like. Because there was a time when there was a lot of demand centralized around maybe AWS and GCP, and then Azure dropped some services that broke the market, and you could see the spread, that the demand was tilting towards Azure. A lot of people were migrating to Microsoft, because Microsoft was offering companies a lot of perks and things like that. Yeah. So, like I said, it's at the bottom of the list. So I'm pushing that upwards. Documentation and learning resources, very important. You need to check if you hit problems, like how quickly do you find solutions to them for that cloud environment. And I think this is where there are problems with most of these cloud environments outside the big three. Yeah. So like if you are working with Yandex now, maybe most of the documentations you see are Russian documentations, because the Russian cloud service provider, most of the people that use it are in Russia, right? So it's going to be a problem for you. Similarly with Huawei Cloud, you probably see mostly Chinese documentations, and it's trouble for you when you are learning. So you need to check these factors too. If you are learning not because of a company, but you're learning because you need to learn by yourself and pick up a skill, a cloud skill in this case. And then the other options too, they are free tier accounts. For instance, AWS will give you 1 year free tier, give you limitations to what you can do. GCP would give you $300 credits. So you need to check what is compatible for you. You can explore both. You can use both simultaneously, and select and go further in the direction of which one pays you more. There is also integration with learning platforms, platforms like Coursera and the rest, learner-friendly pricing, support for learning projects, educational partnerships. Yeah, just like I said, I think Google Cloud had this thing, Coursera, then where you can get credits, and you learn a lot in its cloud platform, right? And then the ease of use and learning curve too. So I would say typically I was more comfortable learning GCP because the navigation was quite smooth, especially with GKE, that's Kubernetes, for instance. The navigation was quite smooth for me. But yeah, there were other things that I was comfortable with in AWS, like some of the services they provided, worked pretty well. Like there were things that I was really impressed by. So you need to factor all of this. And I keep saying at the end of the day, if this is going to be a career for you, you don't need to tie your head to one cloud service provider. You can always expand, right? You can always become cloud agnostic. But to do that, you need to know one properly, like you need to know one to a certain extent. Yeah. Um, yeah, so that is it here. So the next part will be to do a little demo on some cloud services and just talk about them. So I left these as links for you, so you can always just click them and go to Google Cloud Console. Um, so this is instance. Right here from this page, you can see some of the services that Google Cloud offers. You can see API services, admin management. Imagine you're doing admin management on your own, in your on-prem setup. It's a whole thing, really. It's a whole thing. I mean, you can find people that have built tools for this, which is cool. But it's still your setup to do. But it's a whole lot of work. There's cloud storage, compute engine, BigQuery, VPC network, Kubernetes engines. We can go further and look at each of its products and some of the services they offer. Yeah, like management, for instance. You can see they have API management, billing. An admin. So a lot of people come to the cloud for these two parts more, I would say. That is compute and storage. If you are in specific fields like maybe data science and the rest, then sure, and you may be coming to the cloud for analytics, right? BigQuery, PubSub, and all those things. Yeah, a lot of people come to the cloud too because of networks. Yeah. I'm just going to talk a bit around compute. So, oh, and by the way, okay, I'll come to that at the end of the session instead. So, for the compute products, you have different compute services. You have compute engine, Kubernetes engine, that's GKE that I've been saying since, VMware engine, Anthos, and Batch. I commonly use these two more, compute engine and Kubernetes engine. Um, this is not a project I'm being built for, so I won't have access to that. I will just switch to, let me show you so you see what I'm saying. So if I click the compute engine now, um, I currently don't have access to it because I'm not being built for it. So I'm just going to switch to a project I'm being built for. Let's have a- Maybe. Sorry, one sec. Oh. So if I come to the compute engine now, you can see what its contents are like here. it, we mostly use VMs here. So the same way you have your local machine, your computer you are currently using, you can create computers for with specific requirements. Yeah, you can create computers with specific requirements on the cloud. Also, you can say, I want an Ubuntu machine that is going to have this amount of storage, 4 gig memory, 10 gig hard disk, and you pick the series. So it's going to auto determine many of these, right? So many of these are pre-configured, right? But you can also like specify some of the requirements you have, like the hard disk. You can say, oh, I'm working on an ML project now. I need an processor instead. And you have to check certain things like where it is available and things like that. Yeah. So the cloud gives you this advantage to be very dynamic. You can easily just come here and pick, oh, I don't want to use Ubuntu anymore. I want to just use Debian itself. I want to use Red Hat. I want to use Windows, all those kind of things like that. It's all still in one cloud console. You can be a judge of what you require for your own specific. So imagine the alternative, which would be you provisioning a server at home or something like that. And then, you have to get your flash drive, you have to load an OS on it and then put it and then see that, oh, this thing is not working. I need another OS. And then you go over that process again. Or maybe you just have, maybe you're a very big person and you have a lot of flash drives with a lot of OS and you are doing some of this. So the computer engine takes away some of that stress away from you. Another common cloud service would be GKE, Kubernetes. So we must have been hearing Kubernetes flying around a reasonable lot. Yeah. We'll talk about Kubernetes later in this bootcamp, but for now, it is also a very useful service in the cloud space, and it's also very competitive across cloud providers. They try to provide you the best Kubernetes service you can have, right? So, this is something the cloud also provides you. Recently, I was speaking to a friend, and he was talking about how they were trying to set up Kubernetes locally. Now, take note that this is also a cloud to them, but it's a virtual private cloud, right? It's a private cloud rather. Um, so he was talking a lot about how they are having issues with networking these servers together, or when they need public IPs, they want to create nodes and all those things like that. It becomes a problem when they try to manage a lot of these things themselves. Now, it's not like it's not doable, it's doable. But what the cloud takes away from you mostly is the stress of doing it yourself, right? Sorry, I wrote this as code because we would really get used to seeing terminal interfaces like this in the coming weeks, I guess. Um, so the next thing would be, sorry. Okay, so the next thing again would be, oh, you'd be like, um, but if I'm using computer engine here, does that mean I can use computer engine on AWS and things like that? Or if I'm using GCS is Google Cloud Storage, does that mean I can't use storage on AWS or Azure? So this table here is a comparison of the services here that these guys are offering, right? Of the services that these guys are offering, and what they are specifically in each cloud. So it's like a comparative like it's visualizing it comparatively for us to see what each of these services are in different cloud platforms like virtual servers. Now we have instances like EC2 instances and the rest on AWS. We have VM instances, which I just showed you, on GCP, and just VMs on Azure. Platform as a service, you have services like EBS, that's Elastic Beanstalk, on AWS, App Engine, and App Engine on GCP, and cloud services. You can go through this list. This is very interesting. Some common thing would be things like S3, right? So you can see here that object storage is done by S3 on AWS, cloud storage on GCP, and then also BlockBob on Azure. Yeah. Okay. Let me just take this one while it is hot. So Ridwan asks, which section does serverless fall, or is it off cloud? So if you see here now, serverless is also, like, serverless computing is also on cloud, right? You can see Lambda, Cloud Functions, and Azure Functions. What serverless computing takes from you is the need to manage anything, right? So all you would have are like endpoints, right? Imagine you had endpoints to do interact with almost anything on the cloud. So all you would have are like APIs. I don't know if you are a bit familiar with APIs, but you would have endpoints. I say take this endpoint here. It is a Lambda endpoint, and interact with your application on the cloud, interact with the cloud itself, right? So that's what serverless does. It's not, in fact, it's the cloud itself that mostly provides serverless service. Yeah. So it's not off the cloud per se. Abdullah asked if private cloud is also managed over the internet or managed on premise. So I would say most times for you to call it cloud, there is some need for internet, right? But then there are situations where people want to air gap their network. So air gapping is basically disconnecting your network from the internet. Yeah. You don't want any access from the internet, you don't want any access to the internet. So in this case, a private cloud can be also air gapped. That simply means that they're going to be managing everything internally. Maybe they have one port open for a guy that is going to be SSH, and that is having access to their server and making changes and things like that, right? So to answer your question, if a private cloud is also managed over the internet or managed on premise, it's also quite hybrid. It's depending on that setup. Yeah, it's depending on that setup. It can be over the internet, and it can also be air gapped. I don't know if this answers your question, Ridwan and Abdullah. I'm just going to progress while you acknowledge. Okay. Oh, that's cool. I didn't even know. So questions and answers are next. Please feel free to drop your questions. If there's anything you want me to go back and show you anyways, too, you can just tell me. Sorry, I like code to an extent. This double and here is what you would mostly use in a terminal when you want to say and. That's why I have Q and A. So guys, if you have any questions, this would be a cool time to drop some of those questions. If there is something you want me to recap on, this would be a cool time to say so. If you have just comments, by the way, to show we can learn from your contribution, this would be a cool time to also drop some of those. Yeah. GKE and storage slides. Oh, like the demo. Okay. Is it demo or the services itself? Okay, I'm just going to. So I'm going to take What Abdullah asked first, explanation of GKE and storage slides. So we have a whole session for Kubernetes, right? So I don't want to dive too deep into explaining Kubernetes, but for a quick intro, yeah, sometimes people need certain advantages in the cloud. Advantages like scalability, right? Even when you are using the cloud and you are using Compute Engine. Sorry, let me open that another tab. Remember, I said you can create machines with their own OSs on the cloud. That's what is in Compute Engines here. So even when you are using Compute Engine to manage certain things, right? Sometimes you can't do a lot of orchestration yourself. You can't push things around the way you need to. You still need something to manage those servers together. This is where GKE comes in. So it helps you basically distribute. If you have a big app, for instance, an application that is scaling continuously, is getting more and more traction, more users, more traffic all the time, right? You want something to help you manage some of this distribution of workload. You see that every time you create a new VM, it's already full, it's full again. So you need something to help you with distribution and things like that. That is where GKE comes in. Cloud storage, on the other hand, I'm just going to use GCS since we are here. Cloud storage, on the other hand, is, I don't know if you've heard buckets, and if you've heard buckets before, this is what most people refer to as buckets, like buckets on the cloud. So cloud storage is just what the name is. It's just storage on the cloud. I would say Google Drive is some sort of cloud storage, but yeah. But in this case, these are object storage. So you want to store objects from anywhere, really. If you check things like this, let me open something. You would see that there is some sort of, you can store files like this. You would see there is configuration of where it is located, how you can access it. There are permission configurations, the way it is protected, even monitoring and things like that on all of this. This is what these cloud service providers give you. So imagine you wanted to set all of this up on your own. I'm sure it would be a headache. Yeah, I'm sure it would be a headache. So to emphasize more on GK and cloud storage, we'll just be doing this brief intro. When we go deeper into Kubernetes, you'll be understanding more regarding GK. Abdullah, does that, you can acknowledge if that answers your question. Suleiman says, is it possible to use different cloud service providers for an organization, like GCP for storage, AWS for something else? Yes. This, I would call this hybrid public cloud also. So yeah, this is very, very possible. You can say, oh, I want to store my statics, for instance. That's my website. It's just the front end and all those things using CloudFront. Yeah. But I want to store most things, having even the backends, right? Using Kubernetes. I want to store things in buckets on Azure. That's even more. Yeah. You can decide to use as many clouds as you need to. Now the connection is now up to you, whether they need to connect or, the advice would be, if you are going to do that, the need to interoperate should be lesser, right? But if they do need to, that is your own workload. But yes, to answer your question, yes, it is very possible to have different your services across different cloud providers. Abdurrahman asks, which one of the three services is the best, or does it depend on the project you are working on? So again, I would just quickly flip back to this. Did you say services? Oh, Abdurrahman, do you mean platform? Just going to give Abdurrahman 30 seconds to answer, then I'll just talk about platforms again. Okay. So I would, since the only thing I talked about was three in this case were platforms. So I would say Abdurrahman was asking which one of the three platforms are the best. Yeah. That's whether it's AWS, GCP, or Azure, or whether it depends on the project you're working on. Now, these guys have tried to be as dynamic as possible. So it's going to be hard for you to pick it sometimes based on the project you're working on. Yeah. But yeah, there are some specific there are some specifics that comes down to what you are working on. But again, this section as a company is what you should use to judge what works for you. If I am an AI company now and I see that AWS has um they have machine learning processing services, right? Oh yeah, yeah. Okay, Abdurrahman, that's what I'm answering now. Yeah. That they have machine learning processing services. I don't and I can pay for them. I want to pay for them. I don't see why I should maybe go to Azure that doesn't have that. Or maybe I want to work on some sort of um data intensive project and I see Azure has data warehouses, data pipelines and things like that that are very solid and have good track record. I don't see why I should say, oh, I know GCP, I am going to use GCP instead if they don't have what I need. So most many times it's depending on the project. But when you look at the bigger picture outside these three, it now comes back to some of these points here. So you'd see some cloud services don't miss their SLAs. They say we are going to give you 90% uptime. We are going to like 90% uptime on Kubernetes, 50% uptime on maybe buckets or stuff like that. You'll be able to access your buckets all the time, but they don't meet some of that criteria, right? So if you are looking in within the big three, these things on this list, this 1 to 10 here as a company are quite consistent. They try, they deploy new features, they are competing steady back to back with each other. So these things are almost very consistent. But when you start looking outside the big three, that is AWS, Azure, and Google Cloud, you need to start looking at some of these things closer. So yes, it is quite dependent on the project you are working on, but then also like some base factors like what is on this list and even more. You can check out there is more. Um okay. Any other questions, comments, or recaps needed? How does autoscaling relate to the initial VM configurations we set on setting up our cloud, like RAM, disk, etc? Okay, so yeah, I think this is even cool, Ridwan, because I think it was Ridwan that was it Ridwan that asked about Kubernetes earlier. Oh, it was Abdullah. Okay, so Ridwan, this is cool because this gives us a bit context about what we're talking about here. That's the compute engine. Yeah. So you said how does autoscaling relate to the VM? Mm. Currently, yeah, if I provision a VM and I say I want 8 gig RAM and I want this amount of storage, what I am most flexible with changing on that VM is the amount of storage. A lot of other things are rigid. So autoscaling, this is not where the strength of autoscaling comes in. If I say I have 300 users per month, but I'm about to create a feature in my application, and I think that by the end of this quarter, I would be having 2,000 users per month. My servers, as it is, cannot take 300 users, and I don't want to have to manually monitor what happens all the time and go and add another server, and things like that. Yeah, this is kind of where Kubernetes itself comes in. Yeah. So Kubernetes helps you manage your workloads. If you set up autoscalers on Kubernetes, it will tell you that oh, our cluster is almost full, right? Our cluster is almost full and we should what's the name? Okay, so I'm just going to show you an interface here that shows you some of the things happening. Let me see if this is going to look. I think this is a GCP cluster. Okay, this is loading low, but slowly. But normally it should show the statistics here, right? So you can see this is a cluster that has 3 nodes. 3 nodes simply means 3 servers, like 3 virtual machines, and like the VM you're talking about, like 3 VMs. Yeah. if you see here, even when I open compute, you can see these are the same three nodes. They are belonging to those that cluster I was talking about, this playground cluster, right? So where auto scaling will come in now is when something is full on these three nodes and you set up something like an auto scaler, yeah, and there's no more space, the auto scaler will say, oh, okay, it's not just for space, yeah. There are two parts. Yeah, I don't want to go too deep into what we discussed in GKE, but it's mostly either you are auto scaling things like the nodes itself and adding more nodes because there is no space, or you are auto scaling because of the application. Like you said now, maybe the application is using too much CPU or is using too much RAM and things like that. You can say, okay, I want to distribute the number of what pods you that this application is going to use and things like that. Yeah. So I would say what helps the most with auto scaling in this case are tools like Kubernetes. Now, I'm not saying Kubernetes is the only container orchestration system or tool, but it's very good for things like auto scaling based on certain conditions that you have set. Ridwan, I don't know if this answers your question well enough. And I'd like to, I didn't confirm with you if it answers your question well enough to for service comparison.
Hello, good day, sir. For the clarity, I was able to get to the point you were trying to make. And I think hopefully when we come for the advanced class, it is going to
Yes.
be a little bit more better.
Yeah.
Thank you, but it's okay now. I've gotten the concept.
Yeah, and the plan is to be a bit more, engaging, maybe a bit more hands-on in some of the future classes. So it's not just presentation, we'll all be doing something and we at least something basic to catch up. Yeah. So it's not just talk and all.
That would be
Um
very cool. Thank you for that.
okay. So I think we've used like 8 minutes extra on the time we planned to use. So I would assume there are no more questions. If there are any questions, you can still leave it in the comment section or you can leave it in the group. We'll still be answering questions that are in the group. I would say the take home for this week would be to set up your own GCP account because in the coming weeks we may be doing a couple of hands-on classes, right? You'll be doing some things yourself. Yeah. But then we still have like things like time constraints. So it would be a follow as we do kind of situation, right? It may not be like we're in a class and we're trying to break it down very detailed. So it's cool for you to set up your own GCP account. Yeah. Um, I've attached links to each of the take home. Yeah. The next thing will be to play a bit around the Linux terminal, right? So I like this guy. This guy is tutorial, 90 days of death, Michael Kidd. So most of the links I attached to is to this take home from Michael Kidd's 90 Days of DevOps. So you can play a bit with Linux terminal. If you are using a Windows, for instance, Windows has WSL, you can play with WSL to do this. MacBooks and Linux OSs are fine. They would run most of these commands, all of the commands actually. So you can, try some of these. You can explore yourself, try some other things. Just get comfortable with the terminal. It's not to do something big or whatever, but just get comfortable with running commands on the terminal. You can explore version control a bit. Yeah. Get used to pulling and pushing code on GitHub. This is also some exploration. But get used to at least like cloning code from GitHub, pushing code to GitHub and things like that. And then you can also explore continuous integration hands-on here. You just need to get a brief idea on what the concept is about. So yeah, you can just play around most of those. Again, while you are doing any of this, at any point in time, you can just shoot questions on the group. You can tag me, you can tag Timothy, you can tag Rashidat, or any of the organizers. Somehow it would get to us and we would give feedback as soon as we can. I think that is mostly it. But these four steps would really make next week way easier. So it would be cool for everyone to, even if it's a day or two, just spend some time to explore it and so that they don't feel like foreign concepts next week. I see a message in the chat. Oh, Abdurrahman, regarding setting up an account, it is a trial account is always free. You still need to put a card and things like that, but you get like credits, yeah, to use a trial account. On GCP, you get $300 credits. So if you have some challenges with that, you can also discuss with your organizers and maybe find ways around it also. But try to set up your own GCP account. Yeah. I think that would be all. It's was nice. This session was great interacting with you all. Appreciate the feedback also so far. I would say happy clouding. Yeah. Tinuke, I would be handing over the mic back to you. Bye guys. Rashida, are you here? You guys, I think she would be communicating on the group, but I guess that is the end of this session. I don't know if she has some announcements, but I guess she would be doing it on the group. So have a nice weekend, guys.
Okay, thank you very much, Gold, for this session. Sorry, my session was at the other class. And thank you very much for hosting this session. Like, for based on all the questions, yeah, I'm pretty sure everyone like have a very good time. And I know there will be lots of questions. Maybe if you guys did not get to ask them here, please make sure you ask them in the group. And based on all these links, you could just go ahead and try to read something, and if you're having issues understanding any of those that you read, we understand that cloud is quite complex at times and it's hard to understand. That's why the group is there. You could just ask them anything you need to know. Maybe you got hooked in your readings, just come back and ask. And I'm very excited that we have take homes today. So that means like everybody would have something to do, something to come along next class. I can see we are to create a GCP account. Yay. And yes, we'll be diving into the world of Linux. You should explore Git. Okay, this is really exciting. I'm sure like the next class would be really fun. The next class will be taken by Timothy again. So we're so excited for that session. Everyone, can't wait to see you guys next week. But please don't forget, drop messages in the group. If you have any questions, please ask them in the group also. Once more, thank you very much, Gold, for giving us this time and being with us this Saturday. Okay.
Sure, Rashida. Thank you.
All right then. And that'll be the end of this call. Bye, guys.